Every winter, one brilliant reddish star dominates the constellation of Orion. For thousands of years, people around the world have looked up and noticed its distinctive glow. Ancient civilizations connected it with myths, legends, and celestial stories, never realizing they were watching one of the most extraordinary stars in our galaxy. That star is Betelgeuse. Although it appears as a single bright point of light, Betelgeuse is almost impossible to imagine in scale. It is a red supergiant, a massive star nearing the end of its life. If it replaced our Sun, its outer atmosphere would stretch far beyond the orbit of Mars and could extend close to Jupiter, swallowing the inner planets entirely. Despite being hundreds of light-years away, Betelgeuse remains one of the brightest stars visible without a telescope. For decades, astronomers have watched it carefully because they know it is living on borrowed time. Unlike stars such as our Sun, massive stars consume their nuclear fuel at an incredible rate. They shine more brightly, but they also age much faster. Deep inside Betelgeuse, the conditions have changed dramatically over millions of years. Long ago, hydrogen fusion powered the star's core. As that fuel became exhausted, the star expanded into a giant, while new fusion reactions began using heavier elements. Today, its interior resembles a series of enormous burning shells, where different elements fuse at different depths. This complex structure makes the star unstable. Instead of remaining calm, Betelgeuse constantly expands and contracts. Its surface is covered by gigantic convection cells, hot gas rising from deep inside before cooling and sinking again. Each cell is so enormous that it would dwarf the entire orbit of Earth. These movements create noticeable changes in brightness that astronomers have monitored for generations. Then something remarkable happened. Near the end of 2019, Betelgeuse suddenly faded far more than anyone expected. Its brightness dropped so dramatically that even experienced skywatchers noticed the difference. News spread rapidly across the world. Had one of the sky's brightest stars reached the moment astronomers had anticipated for decades? Was Betelgeuse about to explode as a supernova? Observatories around the globe immediately focused their telescopes on Orion. Ground-based observatories worked alongside space telescopes, collecting data across visible light, infrared wavelengths, and spectroscopy. Every possible clue was examined. At first, some researchers considered whether the star had entered the final moments before a catastrophic collapse. But as more observations became available, another explanation slowly emerged. Instead of exploding, Betelgeuse had experienced a massive surface eruption. An enormous cloud of gas was blasted away from the star before cooling into microscopic dust. From Earth's viewpoint, that dust drifted directly between us and the star, blocking a significant portion of its light. The star itself had not suddenly become much dimmer. Much of its light was simply hidden behind its own expanding cloud of dust. This discovery solved one mystery while creating another. It demonstrated that Betelgeuse is capable of ejecting tremendous amounts of material into space in relatively short periods of time. That behavior confirmed just how unstable red supergiants can become near the ends of their lives. Although the famous dimming event eventually passed and the star slowly returned to its usual brightness, astronomers realized they had witnessed one of the most unusual stellar events ever observed so closely. And perhaps more importantly, Betelgeuse reminded scientists that even the most familiar stars still have the power to surprise us. Although the Great Dimming eventually came to an end, astronomers knew the story of Betelgeuse was far from over. The star had reminded the scientific community that it is not a quiet object peacefully shining in the night sky. Instead, it is an aging giant constantly changing as powerful forces battle within its interior. Every day, deep inside its core, nuclear reactions continued transforming lighter elements into heavier ones. Unlike our Sun, which will burn steadily for billions of years, Betelgeuse is living through the final stages of a massive star's life. As each fuel source is exhausted, the core contracts while new fusion reactions begin in surrounding layers. This creates an incredibly unstable structure. Imagine an onion, with each layer producing a different element and releasing energy at a different rate. These competing reactions generate enormous pressure, causing the star to pulse, expand, and shed huge amounts of gas into space. Astronomers have observed giant plumes extending far beyond the visible surface of Betelgeuse. These outflows slowly enrich the surrounding region with material that will one day become part of new stars and planets. In a sense, Betelgeuse is already preparing the ingredients for future solar systems. Eventually, however, every massive star reaches a point where fusion can no longer continue. When iron begins to dominate the core, the process that has supported the star for millions of years comes to an end. Unlike lighter elements, iron does not release energy through fusion. Without that outward pressure, gravity gains complete control. The core collapses in an instant. Moments later, an enormous shock wave races outward, tearing through the star and producing one of the most energetic explosions in the universe, a supernova. Scientists know Betelgeuse will experience this fate. The only question is when. It could happen tomorrow. It could happen tens of thousands of years from now. On cosmic timescales, both possibilities are considered relatively soon. Because the exact timing remains impossible to predict, observatories continue watching Betelgeuse night after night. Modern telescopes monitor changes in temperature, brightness, surface motion, and the gases flowing away from the star. Every new observation helps improve computer models that describe how massive stars evolve before they explode. Researchers are preparing for another remarkable possibility. Before the light from a supernova becomes visible, an enormous burst of tiny particles called neutrinos would escape from the collapsing core. These particles travel almost unhindered through space and would reach Earth hours before the explosion becomes visible. Underground observatories and other specialized detectors are ready to capture that signal if it ever arrives. Scientists also hope that gravitational wave observatories could detect tiny ripples in spacetime produced during the collapse. If both signals were observed together, humanity would witness one of the most important astronomical events ever recorded. Fortunately, Betelgeuse is far enough away that its eventual explosion poses no danger to Earth. Instead, it would become an unforgettable sight. For weeks, the supernova could rival the brightness of the moon and might even remain visible during daylight. People across the world would have the rare opportunity to watch a star dramatically transform before their eyes. For astronomers, it would provide an unprecedented chance to study stellar death in real time using telescopes across the electromagnetic spectrum. Until that day arrives, Betelgeuse continues its slow rhythm. Its brightness rises and falls. Its outer atmosphere expands and contracts. Its enormous clouds of gas drift into space, carrying the elements that will eventually become part of future worlds. The story of Betelgeuse reminds us that the universe is never truly still. Even objects that appear constant to our eyes are changing on timescales far beyond a human lifetime. One day, the brilliant red star in Orion will disappear, replaced by a spectacular explosion visible across our skies. But that ending will also mark a beginning. The atoms forged inside Betelgeuse will continue their journey through the galaxy, becoming the building blocks of new stars, new planets, and perhaps even new forms of life. Its final explosion will not simply mark the death of a star. It will become another chapter in the endless cycle of creation that has shaped the universe for billions of years.